our third type we're looking at are irreducible quadratics. So our advice on the very first type was that before we start splitting them up, we need to make sure that the denominator is as fully factorised as it can be. And so what we're going to look at here are these irreducible ones, where irreducible just means that the factor cannot be factorized. So just for example, x squared plus 5x plus 3 is what we would call an irreducible quadratic, because it can't be factorized. Okay, and we can do that mainly because b squared minus 4ac here is less than 0. Okay, and that would help if I wrote in 0. Right, so that's our little check that we're doing it. So as soon as you get it, don't try and waste your time doing it. Check your discriminant and make sure that actually it is something that can be factorized, because if it can't, then there really is no point. What we want to do is we want to try one of these types. So we want to reduce 6x squared plus 13x plus 18 all over x minus 2 x squared plus 5x plus 3 into its partial fractions. So, as we always do, writing it out, 16x squared plus 13x plus 18 all over x minus 2 lots of x squared plus 5x plus 3. So we've got something over x minus 2. Okay, our trusty fraction there always works. Next thing we're looking at is we're going to have to put something above this x squared plus 5x plus 3 bit. But it can't be factorised any further, and so when we're dealing with that, we actually write it as bx plus c over x squared plus 5x plus 3. Okay, and that is the bit that we need to be mindful of. So an irreducible quadratic produces this type. Partial fraction. Okay, so again, we could find bits of these go away, we could find bits turn to 0, okay, but we don't know that for certain, so we must make sure that we put it in when we're dealing with this. Okay, as always, first thing I'm going to do is I'm going to multiply through by my denominator, and so that is going to leave me then with just 6x squared plus 13x plus 18 is equal to a lots of x squared plus 5x plus 3 plus bx plus c lots of x minus 2. Okay, and we need to make sure when we're doing it, remember, we're going to keep that bit in brackets, because it's very easy when we don't do that to get things lost and we start forgetting things, we start finding wrong values. So, easiest thing to get rid of, that x minus 2, so I'm going to let x equal 2. And so that is going to give me 24 plus 26 plus 18 is equal to a lots of 4 plus 10 plus 3, and then this bit here at the right turns to 0, and so I end up getting 68 is equal to 17a. So 68 over 17 is equal to a, which is 4. Okay, next thing I'm going to do is I'm going to let x equal 0. Okay, we're going to do that because I want to make the bx part equal to 0. I want that bit to go away. Okay, mainly so that I can work out the c value first, and then we can go on and we can work out what b is later. So sticking in x equals 0, I get 18 is equal to 3a plus, I've got minus 2 lots of c. So 18 is equal to 3 lots of 4. I know that. Remembering that bit there, a was equal to 4, so I've got 12 minus 2c. 6 then is equal to minus 2c. And so 6 over minus 2 equals c, which is minus 3. And finally, I'm going to let x equals 1. Okay, there's no other obvious thing to make anything nicer, and I've already used my x equals 0, so whenever we start getting to that point and we know all the other values, try and keep it as simple as we can. So if we run out of options, x equals 0, x equals 1 are always nice ones to try, in the hope that they make things a little bit nicer. So that is going to give me 6 plus 3 plus 18 is equal to a lots of 1 plus 5 plus 3 plus b plus c lots, and there's the other advantage, is I don't have any multiples of b, who's minus 1. And so that gives me 37 is equal to 9a minus b minus c, and I'm just going to multiply those two out because I want to work out one of them in particular. I want to work out b this time. So 37 is equal to 36 minus b plus 3. Okay, adding up numbers on the right hand side, that gives me 39. So 37 minus 39 is minus 2 is equal to minus b, and so b equals 2. And so concluding with what we've got, we had 6x squared. So therefore 6x squared plus 3x plus 13x even. 13x plus 18 all over x minus 2 x squared plus 5x plus 3 is equal to, it should be 13, is equal to, what was my a? Well, a was 4, and so I've got 4 over x minus 2 plus 2x minus 3 all over x squared plus 5x plus 3.